Hello, AP Stats. This is Chapter 4, Section 4.1, Surveys and Samples. And we talked about a lot of this today, so I'm going to go over the first part really quickly. I really want to go over a couple of problems that are in the reading to help you out before our reading quiz next class. But make sure you also read everything. Okay, we talked about population and sample and how we are trying hard to estimate a population parameter using a statistic and a sample, and so we need to get the sample as the best representative of the population when we first collect our data. So that's our goal. We talked about bad ways to sample, include a convenient sample where we get maybe the first 10 people that walk the door, or say, for instance, I wanted to do a study on whether or not how much fruit people eat in a week. Say, for convenience, I took my exercise class in the afternoon and I surveyed all of them. Well, clearly, if they're in an exercise class, they're probably more conscious about their health and might eat better. And therefore, we would get an overestimate of the proportion of people who, or how much fruit on average people would eat in a week. So make sure when you're explaining a type of bias that comes from a bad sampling that you talk about the direction of the bias. Here, this looks to be an overestimate, and provide reason why we might think that a convenient sample might overestimate or underestimate the proportion or the mean that we're actually trying to get. Do you know what bias actually means? I'm here at the bottom. Bias systematically favors certain outcomes. So whenever that happens, the only way to really avoid bias is to try to randomize in order to choose your sample. Another bad sampling technique is voluntary response samples, and this consists of people who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions, often in the same direction, are most likely to respond. So this might happen from online polls, for call-in surveys, from newspaper surveys, where people are asked to volunteer to give their opinion on something. And of course, people with stronger opinions will respond. So again, as you're describing these, make sure you talk about which direction would the bias go in because of the people that would respond. How to sample well? Of course, the main thing we're looking for, like I said, is using random sampling, which is the use of chance. And there's a lot of different kinds of random sampling, but you have to be using chance to select a sample. The gold standard in sampling is simple random sample. Not always the best way to sample, but it's the most basic. And that's basically throwing every name in the hat and drawing it out, or drawing from a random number table. The definition that you need to know for simple random sample: size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. So remember, many methods of sampling can give each individual an equal chance to be chosen. But what's different about a simple random sample or an SRS is that each sample of a given size, each sample of size 10, has an equal chance to be chosen. So, for instance, if I'm in the sample, I have a chance to be in the sample with any other 9 other people, just as likely. How to choose a simple random sample? Of course, like I said, the first easiest way is to use the hat method. Also, on a random number table or a random number generator. Here it describes a table of random digits. There's a long string of digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. where each number is equally likely to be in the 10 digits from 0 to 9. The entries are independent of each other. That is, the knowledge of one part of the table gives no information about the other part of the table. So when you choose a simple random sample, you need to make sure you're describing each one of these steps. First of all, label. How will you number each individual? Are you going to take an alphabetized list, number them from 0, 1 to 10? How many digits are you using? Be careful. If you, for instance, need a total of 50 people, then you're going to number them from 0, 1 to 50, or some people prefer to use 0, 0 to 50. But you need to use 2-digit numbers all the way through. You can't number them 1 through 50, for instance. So describe first how many digits you're using, how you are numbering the people or the individuals. Then we're going to randomly assign. So we'll read consecutive groups of digits from the appropriate length from a random number table. Sometimes you'll be given this table. Sometimes you'll use the table B from the back of the book. Your sample will contain the individuals that you'll find. And be sure to specify if you need to skip any numbers. Like for instance, if we were pulling numbers that went from 0, 1 to 50, we would skip any numbers that were not in that range. So we would not include numbers 0, 0 and 51 through 99, for instance. Make sure you specify that. And if you need to skip, repeat. Of course, if we're designing a sample, we generally don't want to draw the same name twice. So if we hit the number again, we would skip over it. And don't forget step 3, which is to record your sample. Give a list at the end of who or what is part of your sample. Let's go through that real quick. This is an example in your book where called Spring Break on page 213. And this is a school newspaper trying to find out information about hotels for spring break. And it's got 28 hotels, and it wants to choose 4 of them to call and get information about what their amenities are. So we first of all want to describe what we're doing, which is we took an alphabetical list of hotels, and we numbered them from 0, 1 to 28. Another way we could have numbered them is 0, 0 to 27. And so there's that list. And next, we want to look at the random number table. So we've given it just like this here in blue. Go along, and the first 2 numbers are, first pair of 2-digit numbers is 69, and of course we don't have a 69, so we ignore that one. And then 05, and of course 05 is Beach Castle, so that's our first one of our 4. 16, which is Radisson. 48, which is outside the range, so we ignore that. 17, which is Ramada. 87, out of the range. And we see 17 again and again, and we ignore it because we don't want to put Ramada in our sample 3 times, so we skip that. And we have all these numbers that are out of the range that we skip until finally we get down to 20, which is our 4th hotel, Sea Club, and we make sure we list all 4 of those hotels that we get. Sometimes this can take a while. It's faster to put them all in a hat and shake it up and call them out. You can describe either way you would prefer, but sometimes you will be asked to actually go through this process of finding a random sample using a random number table. You can abbreviate random number table as RNP, by the way. Other ways that we've discussed today to sample a stratified random sample. First, you classify population into groups of similar individuals, called strata, and then choose a separate simple random sample from each stratum and combine these to make a full sample. You use a stratified sample, and there are some variables, some kind of factor you think might make a difference? So, for instance, we talked in class about dividing people into grades before we took our sample and then took a simple random sample out of each grade. But we would only want to do that if we think, for instance, that ninth graders would clearly have a different opinion about something than fourth graders. So we might want to make sure we have a representative for each grade. If perhaps we were trying to find out what the average distance people travel from school, well, there's no significant difference in ninth graders and 12th graders as far as how far they come from school. So it would make sense to divide it into strata of grade level for that. So you always need to describe, if you're using a stratified sample, as to why did you use that variable to stratify. Why would that help in your sampling to make it more representative of the population? The other main type of sampling is cluster sampling. This one is actually much more convenient. You would first divide the population into smaller groups. Often these clusters should be a mirror of the original population. So, for instance, if we go back to the example of using clusters instead of strata, clusters that already exist, like grades, it would be appropriate to use those as clusters if we were doing the sample, as we said, ask how far they travel to school each morning. So if we took, for instance, randomly decided, threw out of a hat, every grade coming from 1st to 12th grade, we drew 5 of them out of the hat. We got 1st grade, 3rd grade, 9th grade, and 5th grade, for instance. And then we took everybody in each one of those grades. That would be a cluster sample. So you're first randomly getting those 4 grades, and you're taking everybody in them, 1st grade, 3rd grade, 5th grade, and 9th grade, for example. And each one of those grades is a small version of the whole population, rather than in a strata where they are breaking them into parts because we feel that each grade might have a different opinion about something. And the strata, we would take a few people out of the 1st grade and a few people out of the 2nd grade and a few people out of the 3rd grade and so forth for simple random sample out of each grade. Okay, so let's look at this example, and this comes out of your book on page 218. And it says we have student council wants to conduct a survey during the first 5 minutes of the all-school assembly. The auditorium looks like this picture. And they would like to announce the results of the survey at the end of the assembly. Student council president asks your statistics class to help carry out the survey. So first of all, we want to do a simple random sample. In simple random sample, of course, we would choose 80 of the seats at random, so either with a random number generator, or we would put all these numbers from 1 to 800, definitely bigger than our school, in a hat. We would shake it well. We would pull out 80 seat numbers, shaking it between each time we draw, shaking it well, and then once we get 80 seats, that is our simple random sample. The advantages of that plan, well, it's pretty easy to do. However, there would be a chance that we might have too many 12th graders or too few 9th graders, depending on what kind of variation we got. So there could easily be classes that were underrepresented. So a better way might be to stratify. So the students in the assembly are already seated in grade. So perhaps we just take those grade levels and make those our strata. It says down here at the bottom that 9th graders are in seats 601 to 800, 11th graders in seats 201 to 400, and so forth. So they're already divided. So within each class, we take 20 freshmen, 20 sophomore, 20 fifth grade, and so forth. So that, and we're taking a simple random sample in each grade. So take all the ninth grade numbers, put them in a hat, choose 20 of them, make sure we're mixing as we go, then do it with the 10th grade, then do it with the 11th grade, and so forth. We could also do this, of course, with a random number generator. That would be our stratified sample. The advantage of it is we would make sure we know what grade would be under or overrepresented. Each student still has the same chance to be selected, especially since there's an equal number of kids in each grade. So in this case, that might be a better sample. For a cluster sample, with the way the students are seated, each column of seats from the stage to the back of the auditorium could be used as a cluster because each one of those would include kids from each grade and the same number of kids from each grade. So note that each cluster contains students from all 4 grade levels. So since there are 20 clusters, each with 40 seats, we would need to choose 2 clusters at random to get the 80 students that we need. So we could again name each cluster if we wanted to and choose them out of a hat, or we could use a random number generator and pick numbers 1 to 20, select the clusters we want. So we're talking about these are the clusters here. There's one, and so forth. Of course, there's lots of seats in between here. So if we pulled out 20, then we'd get that last cluster, for instance. Now, the advantage of this, it's very easy since you don't have to spend a lot of time. You only need to select 2 columns out of the hat. Also, because of the seating arrangement, each grade will be equally represented. However, if there's a pattern in the columns, such as students will be probably sitting together, then that might cause some type of bias. So you have to be careful on cluster samples because of that. Or maybe all the late students, I think, might be sitting closer to the door and they might think differently about things. So those are our 3 basic times how we perform. Make sure you're always willing to talk about what's the advantage of each one. Now, I'd like you to read carefully over all the different kinds of bias. Remember, we have sampling, bad sampling, and survey bias, which are very different things. So make sure that you clearly know the difference. And also take time to do just 2 problems tonight from your YMS. On page 227, you need to do number 19, which is going to be actually filling, just like I just did, numbers from table D and designing a sample. And then number 21, which will be similar to the problem we just did, finding a simple random sample, a cluster sample, and a stratified random. Thank you.